Hello and welcome to a new lecture. In this lecture, we focus on the processes and controls that ensure sensitive data does not fall into the wrong hands once it leaves primary systems or enters less protected stages of the data lifecycle. We will examine media sanitization, data loss prevention, DLP, and how data should be handled throughout its entire lifecycle, from creation to destruction. This is where policy meets precision. If classification and ownership define what is essential and who is accountable, media sanitization and DLP enforce that importance at the edge when data is copied, moved, shared, or disposed of. These topics are heavily tested on many exams and equally critical in real-world security management. Let's begin with media sanitization, which refers to the secure and deliberate removal of data from storage media to ensure that it cannot be reconstructed or recovered. Media sanitization is essential during equipment decommissioning, lease returns, hardware upgrades, incident response, and even internal reassignments. The core idea is simple. When storage media leaves your custody, the data must go with it. But execution is where things often fail, either due to poor process, false assumptions, or misunderstood technology. There are three primary methods of media sanitization: clearing, purging, and destroying. Clearing involves overwriting data using standard software-based utilities, often for reuse within the same security environment. For example, deleting user files from a workstation using a secure deletion tool before reissuing it to another employee. Clearing is considered low assurance because data may still be recoverable with specialized forensic tools. Purging is a more thorough method, designed to make data irretrievable even with advanced tools. Techniques include cryptographic erasure or full drive overwriting using standards like DO 5220.22-M or NIST SP 888. Purging is often required before media is reused in a different security context. Destroying is the most secure, involving physical destruction such as shredding, degaussing, pulverizing, or melting. This method is used when media is being permanently retired or when classified data must never be recoverable. Media sanitization policies must be defined, documented, and enforced across all media types: magnetic drives, SSDs, USBs, CDs, mobile devices, backup tapes, and cloud storage containers. SSDs introduce special challenges due to wear leveling and hidden sectors that may retain data despite overwriting. In such cases, encryption-based sanitization, by destroying the encryption keys, is often the only reliable option. In cloud environments, deletion must consider replication, snapshots, and multi-region storage. Contractual and architectural safeguards must ensure that deletion requests propagate across all instances and that residual data cannot be retrieved. Sanitization also applies to non-traditional media, such as printers, copiers, IoT devices, and mobile phones. These devices often store logs, cached documents, configuration files, and credentials. Before disposal, they must be reset, wiped, or physically destroyed according to policy. A printer sold without sanitization may still contain stored invoices. A returned router may retain Wi-Fi credentials. A cloud VM snapshot may retain confidential memory artifacts. As a CISSP, you must ensure that your organization has a formalized sanitization policy, technical tools, chain of custody procedures, tracking. Let's now transition to data loss prevention, a key control category for protecting sensitive information from unauthorized disclosure, whether accidental or malicious. DLP systems monitor, detect, and in some cases block the transmission of sensitive data across endpoints, networks, email systems, cloud applications, and storage repositories. The goal is to prevent confidential information, such as personal data, financial records, source code, or intellectual property, from leaving the organization's control perimeter. There are three main types of DLP: endpoint DLP, network DLP, and cloud DLP. Endpoint DLP agents reside on laptops or desktops and monitor activities such as copying files to USB drives, printing documents, or capturing screens. They can enforce blocking, alerting, or logging action. Network DLP operates at gateways, inspecting email, web traffic, or file transfers to detect sensitive content based on pattern matching, regular expressions, fingerprinting, or machine learning. It can block file uploads, quarantine messages, or flag policy violations. Cloud DLP, increasingly important in SaaS-heavy environments, monitors cloud apps like Office 365, Google Workspace, Salesforce, or Dropbox for policy violations. This may involve API-based scanning, real-time policy enforcement, or integration with cloud access security brokers or CISSPs. DLP is effective only when it aligns with data classification and policy. If data is not classified, DLP cannot distinguish between a harmless document and a high-risk one. Effective DLP requires well-defined rules. For example, blocking transmission of files containing 10 or more credit card numbers, alerting when employee data is shared externally, or warning when source code is uploaded to GitHub. These rules should be tailored to your business risks, tested regularly, and updated as threats evolve. DLP is not set and forget. It must be tuned, reviewed, and balanced to avoid false positives and business disruption. Another challenge in DLP is evasion. Users may zip, encrypt, or rename files to bypass detection. Advanced DLP systems may use content extraction, decryption with approved keys, or behavioral analytics to counter evasion. Integration with endpoint detection and response or EDR tools can also improve detection context. Cloud-native DLP tools may also enforce zero-trust policies, such as denying downloads of sensitive files unless the device is compliant, managed, and in a trusted location. Now let's widen the lens and examine the data lifecycle, which frames everything we've discussed in a continuous process, from data creation to secure destruction. The stages are generally defined as create, store, use, share, archive, and destroy. At each stage, specific controls and responsibilities apply. During creation, data must be classified and labeled. During storage, access control, encryption, and backup policies must be applied. During use, audit logging, DLP, and access governance ensure appropriate handling. During sharing, encryption, masking, and usage agreements define boundaries. During archival, long-term integrity and accessibility must be preserved, often in offline or cold storage formats. During destruction, sanitization or physical destruction must be applied to prevent data recovery. CISSP professionals are expected to map controls across the lifecycle, not just at a single point. For example, a health record must be encrypted during storage, restricted during use, audited during access, protected during transmission, retained for 7 years, and securely destroyed afterward. If any of these stages are misaligned, say, the backup is unencrypted or the archival copy is kept indefinitely, the entire lifecycle is compromised. One major risk across the lifecycle is data sprawl, the uncontrolled replication of sensitive data across devices, emails, logs, test environments, and personal accounts. DLP can detect some of this sprawl, but prevention requires governance, role clarity, and system integration. Organizations should adopt data minimization and least privilege principles, combined with periodic data inventories, automated tagging, and lifecycle-aware architecture. Cloud environments should include automated classification, retention tagging, and cross-region visibility to ensure data stays within governance boundaries. Let's conclude by recognizing that data control is not just a matter of compliance, it is a core element of organizational trust and risk management. Whether it's a customer's personal record, a board presentation, or source code, every piece of information your organization owns must be managed from cradle to grave. Media sanitization ensures that old devices do not betray secrets. DLP ensures that insiders and misconfigurations don't expose sensitive assets. And lifecycle management ensures that data does not outlive its purpose, becoming not only obsolete but dangerous. To summarize, media sanitization removes risk from end-of-life devices. Data loss prevention safeguards information at rest, in motion, and in use. Lifecycle controls ensure alignment from creation to destruction. As a CISSP, your mission is to ensure that all three are embedded into technical design, business processes, and human behavior. This is not only how you protect data, it is how you govern its existence. Now ask yourself, does your organization have a documented media sanitization policy? Are SSDs and cloud resources included? Is DLP deployed on endpoints, networks, and cloud services, and are the rules aligned with real business risks? Are lifecycle stages mapped to controls? Are retention and disposal policies enforced automatically? And does your data governance program see the lifecycle as a chain, where the weakest link becomes the biggest breach? These are the questions that CISSPs ask and answer daily. Thank you again for your diligence and focus. You are now equipped to lead with clarity in managing the lifecycle of your organization's most valuable asset, information. Let's keep advancing.